All right, everybody. Hey, welcome to our fourth general body meeting this semester. This one's going to be pretty low-key, kind of short, but we're going over some important stuff, so it's good that you're here. I know half of our team is over at our solar park working on hybrids, which is okay. They can watch it later on our video. And some of the stuff I'm going to talk about is pretty relevant to them, so I hope you're watching it later. Just to get started, what we're going over today, we're going to talk about the static motor test that we did last weekend, because there's some pretty important results from that. We're going to look at our CAMSAT project and look at the timeline for that, because hopefully we can finish it up this semester. And then I'm going to introduce our big competition that we hope to do for the rest of the year, and our plans for that at the very end. So just to start off, that static motor test didn't go very well at all. Our motor that we had actually exploded. You can see in that top left picture, that's part of the casing. And this was our motor test stand, and it's pretty beaten up. So that project to design a new motor test stand just got a whole lot more important. We think that the problem wasn't actually with the propellant that we made. We think it was with the casing. There was a part of the casing that was like overheated, and when we actually did this burn, it looks like that's where the casing failed. So the problem isn't our propellant. That was okay. But what this does mean, there's a lot of things we have to look at in the future so that something like this doesn't end up happening again. As far as failures go, this was probably the best way we could have failed because nobody got hurt, nothing was too damaged, so like we're actually in an okay spot, and this illuminates a lot going forward. And this is relevant for both propulsions research that did this and for hybrids that's looking to design their own propellant. When we do this, we want to take it from less of a hobbyist approach and analyze it from an engineering standpoint moving forward. So before we actually go ahead and light these motors, we want to have an idea of exactly what's going to happen. So we want to predict all of the internal components. So we want to know what the pressures are going to be, how the chemicals are going to react, and have a really good idea of the stress state on all those casings so that it doesn't fail again. So before we do any of that, each of these like major bullet points have to be hit. Not necessarily in like a formal report, but we have to have an idea of what's going on. And I think that's okay. We can handle that. That's totally fine. Moving forward, we've got our CAMSAT project. Our last meeting, we only had like very few people go. So instead of building 2 rockets for our CAMSATs, we'll probably narrow that down to 1 because we don't really need to build 2 rockets for the amount of people who showed up. That being said, this is a great opportunity to learn. The person who's heading this up is really experienced in rocketry. She's level 2 certified. She's going to walk you through the entire process. So if you want to learn, this is a good project to get involved in. There's going to be a meeting next week, and I have the details for that at the end of this slide, or not at the end of this show, so you can check that out then. At the next meeting, we're looking to finalize the design for that rocket, and hopefully launch November 30th in Gainesville. There's a field by our energy park where they've got a bunch of cows. I think it's officially the UF Beef Research Place. I'm not sure. But that's where we're going to launch, so we don't have to actually travel far enough, like we have to do with all of our other launches. So this is pretty good. And I guess that's all I want to say about that. And up next is our big competition that's going to take center stage for us moving forward. And that's the Intercollegiate Rocketry Engineering Competition. I'm introducing this with a little bit of hesitation because there's still a couple hurdles that we have to pass before we can actually fully commit to this. I do bring it up now because it's starting to get a little bit late in the game and we have to start working on it. Before we can actually say with 100% certainty that we can commit, we have to get a little bit of funding stuff done on the back end to make sure we have the available money to actually compete in this and do everything we want to do with our rocket. And that should be done probably in the next few weeks. So we'll confirm this in the next few weeks, but we do need to start working. This competition is put on by the Experimental Sounding Rocketry Association. It's an international competition. There's teams from Canada, teams from Brazil, I think. Last year, the team from Canada won. It's all teams like our skill level that actually fly out to Utah and compete. And to summarize the competition, it's to design and build and launch a rocket, fly up to 10,000 feet with a payload that's 10 pounds. And both of these are specs that the rocket team hasn't done before. So this is a bigger challenge than we've seen in the past. So we're scaling up and trying something new, which is an interesting challenge for us moving forward. When we actually go to the competition, we have to provide a poster that talks about all of our stuff. So all of our design parameters, what our simulations look like, all that. That's what's going to be on our poster. And in comparison to the competition we did last year, if any of you are familiar with it, it's the University Student Launch Initiative, and that had a really lengthy design process. As opposed to just one poster, it was several extensive reports throughout the year. I think we had 3 or 4 that were all like 150 pages each. So we may be looking to incorporate some of that stuff internally, because that stuff really is helpful in terms of developing our engineering skills and making sure that our rocket actually works, as opposed to just going there and then having some sort of poster. If we can actually itemize everything that we need to, those types of reports work by having us engineer on a higher level than just getting it done. So we'll try and do some of that. Maybe not the same extent of 150 pages, because it would be a little ridiculous just to require that internally. That's not necessary. Some other things about the competition: everything has an emphasis on student-built components. So instead of going out and buying our airframe or maybe even a nose cone, we're going to try and build everything in-house. So that's laying our own carbon fiber tubes or fiberglass or something like that, build our airframe ourselves. And there's also the potential for using a student-built motor. That's why there's kind of been an emphasis on propulsion's research so far. Right now, the plan is to use something commercially available. If later in the year we determine that we're comfortable enough building our own motors, we can go ahead and sub that in. But until we reach that point, the plan is to just use something commercial. So we won't get the maximum amount of points for building a student-built motor, but I'd rather do that and have our rocket work than have the entire thing blow up like we saw in our test last weekend. And obviously, they want us to be able to recover it and have everything reflyable and not have anything break on the rocket. I'll send this PowerPoint out later, and you can check out this link that has all the rules, all the regulations, and all the details if you want to look at it later. For us, we're actually thinking about doing 2 different payloads. The first one is some sort of energy harvesting idea. And the idea behind this is that when our rocket launches, there's a lot of wasted energy. Everything from the drag, from all the thermal energy from the motor, that's all wasted. So we're going to try and recover some of that and see if we can generate some sort of power. So on our fins, we might be using piezoelectrics to gather up the energy from the vibrations on the fins, the drag forces, and turn that into some sort of energy. And then we're also thinking about using thermocouples on our motor, see if we can get some of that thermal energy. And then on the right, that's actually a diagram of how a thermocouple works. And the idea behind it, I'm not an expert on this, but the idea is that if you've got 2 different types of metals at a heat source, they'll each create some sort of voltage difference across their own surface. Normally, you wouldn't be able to harvest that, but because they're different characteristics, just material properties, each voltage difference across each individual piece of metal. I'm probably explaining this and jumping over my words. Okay, I'm going to start over. Each metal heats up differently and has different internal characteristics, and because of that, there's a voltage difference across them. So if we can take that voltage difference and try and generate power from that, that's something we're really looking at, and that's how the thermocouples work. The other payload we're looking at is an analysis of GPS systems. Recently, the Russians just finalized their GLONASS constellation, which is just like the American GPS, so their equivalents. So now a lot of chips that they do for GPS actually include both GPS and GLONASS, so that you can operate on both of their satellites. And the idea, as this picture shows, is that you can just see more satellites up in the air and get a better image. And there's been a lot of testing to show that this combination of GPS and GLONASS works a whole lot better for latitude and longitude on a flat plane, but there hasn't been a whole lot of information about looking at altitude. And typically in the past, GPS hasn't been the best at taking altitude data as compared to like barometric pressure or something like that. So our idea is to have one GPS chip on board and one combination GPS and GLONASS chip on board, and see if we can see which of them actually generates better altitude data. And that's something that there hasn't been a whole lot of research into. So that's a pretty neat payload idea too. Because this is a really huge project, it's important to lay out exactly when we plan to do everything. This is our timeline. As you can see, the first date is November 15th. That's just a couple of weeks away. So the next few weeks are going to be pretty crucial. In laying out the framework for the rest of the year, because we do have to submit, each of these red dates up there is something to submit to the competition that they're requiring. And that's our first submittal date, is November 15th. Moving on from there, our PDR is a preliminary design report. From that, on January 15th, when we come back, that's a paper submitted to them. And internally, I want to have all of our design work completely done. So at that date, I want to be able to take any SolidWorks file or OpenRocket simulation or something like that and point to it. And if anybody has a question about how this component works, we have an answer right then, and every detail is taken care of. In February, we want to launch a subscale, so something without all of our electronics components, scaled down considerably, a really cheap motor. Don't go to 10,000 feet like the competition requires, but something maybe 2,000 or 3,000 feet, and just test all of our systems, so make sure our recovery system works and all of our design is appropriate. So that's what we'll be doing in February. In March is our critical design review. At that point, I want to have all of our testing done. So for example, if we've manufactured some body tube, I want to do some stress testing on there and have that completed by then, run some checks in our electronic software. All that should be done by then so that we can launch a full-scale rocket early April. Should the early April date not work, the April 5th, we can push that back to the 19th. But it's better to have it early because the semester is winding to a close, and that gives us a little bit of a time after April 5th to fix anything that goes wrong. The FRR, the Flight Readiness Review, is just an analysis internally that says, yes, we've done everything. Every component is taken care of. We've tested it all. We've flown this, and this is ready to fly at competition. And I want to have that done internally and then have our poster completed late April. That way, even though the competition is not until June and they don't require a report until May, we're done at the end of the semester and we don't have to work on anything until the competition rolls around. And our competition is in the middle of, that should be June 26th to 28th. It's not a 12-day competition. And we should just go over there and fly once, and that's over in Green River, Utah. The logistics of getting there, we haven't quite worked out yet because everybody's summer plans are probably pretty malleable at this point. So as we get closer, we'll figure out exactly how that's going to work out. And that's basically all I have. There's a lot of upcoming meeting and events just because this competition is ramping up quite a bit. So here's everything that's going on. Our structures team should be meeting up sometime early next week. For tool training and safety, this is something as we move into manufacturing, it's important to know how to use all the tools and equipment we have and how to use it safely. So next Wednesday, we'll be doing some of that at our energy park. The directions to that are available, I think, in our second general body meeting PowerPoint that's available online. All of our PowerPoints and videos of our meetings are available online, so check back for reference earlier. And that's just what we have. This tool training is just what we have at the energy park. We may have another one that's set up in the Student Design Center to focus on lathes and mills and all of that, because we'll probably be using those tools too. Our CAMSAT meeting that I spoke earlier is next Thursday, actually on Halloween. And I spoke to Lauren, who's leading that, and she's requiring everybody come in costume. That's mandatory. And we're actually setting up a rocket dynamics and simulations workshop with Dr. Lind, our faculty advisor. And that's going to be probably on a Saturday, and it might be a pretty lengthy lecture, operating at a little bit of a higher level than we've done in the past so far. And that's going to be actually taking parameters of the rocket and understanding how it flies and how it works. And so the date for that hasn't been set up but it's going to happen. When we know, I'll let you all know. And our next general body meeting will be 2 weeks from today. Does anybody have any questions about anything I went over? Our payloads, our competition, the CANSAT project, anything from today? Yeah.
I know this is pretty far down the line. How does everyone usually get on the competition?
So last year, our competition was actually in Alabama, and anybody who wanted to go, we just got into a car and drove up there all as a team. This year, that might be a little trickier because it's farther away and it's in the middle of the summer, so we haven't really worked all that out yet. I imagine that if you want to go and potentially we've got the funds to pay for your travel, or you're willing to pay on your own, you're totally fine to go. So anybody who's available at the time, we'd love to have you out there. Anything else? All right, well, thank you all for coming.